Hello, CheersKevin here, and welcome to another video on programming in kOS. This is part of my kOS for Newbies series, and I've got to be honest, I am really excited about today's episode. Last time, we didn't write much. We stole broken code and fixed it. Why learn to fix bad code before we even write our own? Well, we're working in a language that exists solely within the context of Kerbal space program. And that means it's not always as simple as Googling the error message you get to find the hundreds of other developers who've encountered the same bug you have. Our code will break down, and we need to be our own mechanic. Today, we're going to continue on our mission to get this craft to the moon. And I should mention, for those who may just be joining us, that this is a stock craft. We're flying the Kerbal X with a kOS core slapped on the side. So far, we've managed to get the vehicle to orbit, but we still have circularization and transfer maneuvers to worry about. To tackle that, we're going to figure out a way to execute maneuver nodes. It may seem silly to use a maneuver node to circularize our orbit, but there's an important reason for this. It allows us to express two separate ideas in our code: what we want to do and how we want to do it. If we can execute a maneuver, then we can execute any maneuver, be it a circularization or a transfer to Joule. And on the flip side, if we can express what circularization means, the what we want to do, well, we can swap out different hows for getting it done. Fire the rockets, use RCS, or tell Jeb to get out and push. To make this separation, we're going to use my favorite feature of any programming language: functions. Functions are a way for us to group instructions together, which allows us to literally level up. Programs can get big and complicated, and the way we deal with that is with functions. Programming without functions is like building a house entirely on your own, chopping the wood, digging a well, twisting your own copper wire. Programming with functions is buying the lumber, hooking up the water supply, and hiring an electrician. When you use functions, you can think about your project at a higher level without getting buried in minutia. Now, with this craft in a stable orbit and a judicious quicksave applied, it's time to get to work. So I'm very excited. Let's dive in here. We're going to change this broken launch script from the last episode to fixed launch script. You can get a copy of this code down in the description if you want to play along. And we're going to write our first function, and this is based off of the comments that some of you left in the previous video about, hey, maybe we can write a function that does the staging and worries about this whole waiting stuff for us so that we don't have that issue of trying to stage multiple times too closely together. So we're going to do that. I'm going to write function do safe stage. And you can give this kind of any name you like. I'm going to open up curly braces, which is the way that we group lines of code. And I'm going to go ahead and write wait until stage : ready, and put a dot after that. And then I'll say stage. So that's all we're going to do. Now, do safe stage is a function that's going to do both of these things whenever we call it. It's going to wait until we're actually ready to stage, and then it will stage. So if we try and do it twice, if we call this function twice, it'll go ahead and pause between the second one to make sure that KSP can actually do it for us. Now I can just replace all the instances of stage. I can double click here, and I believe I can hit Control F2, although it's going to be different depending on, for those of you on a Mac or whatever. And yeah, now it's got a cursor for all of those. I'm going to change these to do safe stage. And I'm going to put an open paren and a close paren. We'll talk about why that is at a later point in time. And then hit escape. And there we go. Now I've replaced all instances of stage with do safe stage. Of course, you can also, if you don't have that, you can right click and say change all occurrences. And we'll just do that. Do safe stage. Not sage, stage. Now, I should also mention, we're going to be spending a fair bit of time in the code right now. At the very end, I'll hop over into KSP, and we'll kind of debug the issues really rapid fire real quickly. It's a lot easier than hopping back and forth all the time. Now, of course, we've replaced all these instances, and that means that up here, we've also replaced those. We don't want those to be changed, so we'll change this back to stage. We'll change this one back to stage. Ready. But everywhere else where we were otherwise doing staging, we can just say do safe stage, and we can get rid of that wait statement now. So that's great. Let's do some other cleaning up. We left some print statements in here. Let's go ahead and get rid of those. Let's get rid of this because it's commented out. We don't need it. And the rest of this is whatever it is. Now, we can use functions to group code like this for utility. We can also use them to make our code clearer. And I'm going to go ahead and wrap some of this stuff. We've already used kind of line spacing to group these statements in a sort of intuitive way. We can actually use functions to give them names so that we can refer to them and know what they're actually supposed to do. So I'm just going to do that right now. I'm going to say function launch and put that. Of course, it's going to add those curly braces, which is fine, and I'll just go ahead and indent these. Then right below that, I'm just going to call the function right away. So this is the way we call the function with the parentheses, and we just name the function. We say function blah, and then it's saying, hey, whenever you try and run this function, I'm going to run all three of these statements, and that's great. We'll go ahead, we'll call this do ascent. Oh, that was another thing that I want to do. It's a good habit to get into. If you have things, particularly words that are not always intuitive, that are not intuitively verbs, sometimes it's helpful to use something like do ascent. I'm actually going to do this as well. I'm going to change all occurrences to do launch, because we talk about the launch and etc. as a noun. Do launch makes it very clear if you're reading this code without any context, well, we're actually doing a thing. Here is where we do our auto staging magic, and I'm going to leave that alone for a moment. And then at the very end here, we're locking the throttle to 0, we're locking the steering to prograde, and then we're waiting until false. This is really our shutdown logic. These three lines really kind of go together. So I'm going to say do shutdown. Oops, bad habit from other languages. We'll go down here, do that, and indent these. And we do need to make sure that once we've put these things inside a function, the code inside here isn't going to run unless we call the function by doing this. If we leave this alone, it's going to say, cool, I now know about this function called do shutdown, and if anybody ever calls me, I'm going to do all these things. But without actually calling it, the code's never going to get executed. That's why I'm putting all of these things down here. It's also important to know that if we were to put this up here, it's not going to work. In some programming languages, that's fine because it goes through the whole thing, but no, we got to make sure we put everything in the appropriate order. So now there's this whole thing of until apoapsis is greater than 100,000, blah, 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 blah. And then what are we doing in here? Well, we're saying if the available thrust is less than old thrust minus 10, do a safe stage, wait a second, and then set our old thrust to ship available thrust. So we're trying to auto stage. We're trying to detect when we have a drop in our available thrust. So I'm actually going to comment out this whole thing, which I believe you can do with Control K and then Control C. Yeah, thank you for that, commenters. I appreciate it. And then I'm going to try and rewrite this in a way that uses functions as well. What I want to do is say until apoapsis is greater than 100,000, and then I'll do here, and I'll just say do auto stage. That's what I want to be able to do, right? So that implies that I need a function called do auto stage. So let's write that. Now, do auto stage is going to go, hey, if ship available thrust is less than old thrust minus 10, then do safe stage, wait 1, and then set old thrust to ship available thrust. But now there's a problem, and that is that there's this line set old thrust to ship available thrust that needs to exist outside of this function. Because if we put things inside this function, these functions are kind of like little isolated rooms. And if we create a variable inside, it's not going to leak out. So what we did here is we said, hey, set old thrust to ship available thrust, right? If we were to just copy this in. Now that means every time we call this function, it's going to set old thrust again. And that's not what we want to do. We want to know, hey, what's the old thrust? And we'll set it if it doesn't exist. But really, we want that value to persist no matter how many times we call the function. Now, we can do this by saying if not defined old thrust. So we're saying if there's no variable that you can find called old thrust, then we can set it. And I can do that, set old thrust. We can put that there. Set old thrust to ship available thrust. Available thrust. And that's all we really have to do. So we're just saying, hey, if we can't find it at all, if it's never been talked about, then we'll go ahead and do it this one time, which means that then when we immediately check if there's a difference, there's not going to be a difference. But on subsequent calls, it'll go ahead and it'll say, hey, do we know about anything called old thrust? Well, yes, we do. Except there's this whole issue with set. Now, this is something that's going to change a little bit based on some behavior in kOS, whether or not we're talking about a variable that is internal to these curly braces or external. What we can do is we can say, hey, I want this to be global. I want this variable to exist outside of this function. What I'm going to do is rewrite this as declare global old thrust to ship available thrust. And there's actually a directive, for those of you curious, there's a directive where you can make the whole thing imply globals if it doesn't find anything, and it's a whole bunch of stuff. We won't worry too much about that, but because we explicitly want this to be global, I'm going to replace those in here. So what that means is that if someone outside of this function were to try and call old thrust, they'd be able to get access to it, and that's just fine. We're allowing them the ability to do that. So with that code written, we can get rid of our commented code. And again, we're doing a little bit of refactoring. We're going to get more into writing our own code, but I want to get you used to the idea of these functions as ways that we can group related code first. Now, one thing you'll notice is we've kind of put everything in these little sandboxes except for this line of until app-wapsis is blah. And that's really fine because, well, we're repeating this function until, and it's just one line, so we're not worried too much about it. And we have this lovely function do auto stage, and that's great. But of course, this doesn't make things particularly readable. We still have to scroll through here to figure out all of the stuff that this is doing. So I'm going to create a function at the very top here called main. And what I'm going to do is I'm just going to extract all of these top-level function calls in the order that they were in. So we have do launch, do ascent. What else? What else did we do? Until app-wapsis, do auto stage. And then do shutdown. And I'm going to put that in here as well. I can go ahead and indent these. By the way, if you just hold shift and up or down arrow and then you can hit shift and it's going to go, hey, or you can hit the tab key and it'll indent those for you, which is nice. As another aside, we could also, since this is a single instruction and not a group of instructions, we don't technically need the curly braces, but I'm going to leave them there just for readability's sake. And now we can see really what this script is doing at the very top of the file. We can say, hey, main means do the launch, do the ascent, until app-wapsis is greater than blah, do auto stage, and then do the shutdown. This is what our program is doing. And at the very bottom here, I'm going to actually call that main function. I can clean up some of these empty space lines. And are there any more? Nope, we're good. Okay. Now I can collapse these functions as well, because we really don't care about the details. At our top level, we care about, hey, what is our script doing? And if we care to drill down and go, hey, what does do safe stage, then great. In fact, if I wanted to be really pedantic, I could go ahead and say, hey, do safe stage is more of a helper function. So we're going to put that at the very bottom so that when you're reading through this, this code, it really tells a bit of a story. That at the very top, it's kind of the table of contents. Then you have these chapters. And then the little helper things are, smaller functions that may be called from these chapter level functions, if that makes sense. So with this code refactored this way and using these wonderful little functions, I'm going to jump over into KSP and see if we get any bugs. We'll jump back in and try and fix them all up as quickly as possible. Well, this looks good. This looks promising. It seems to do everything it's supposed to do, as long as it cuts off when we get to the when it gets to the app-wapsis. I think we're pretty much good, right? It'll do its whole shutdown, and then we'll call that a day. Is it going to do that though? Open question. Yep, there we go. It's in shutdown. We can go ahead and get out of time warp. And then I'm just going to kill it by hitting Control-C. And then just to verify, let's edit debug.ks. Whoops. That's right. One, it's edit path, I think. Edit path. Edit path 0/debug.ks. Nope, that's not going to do it. Right, okay. Switch to 0. We can switch which drive we're currently on, and then edit debug.kOS. I just want to make sure that we're running the fixed do launch script. You can see that code that we wrote down here. If I resize this and all that stuff, whatever, that's fine. But we verified that it's running on the new version of our code, and our code just happens to work right out of the gate. That's pretty remarkable. That doesn't happen very often. So now that we know that our code actually works, I'm going to change this to functional launch script. Fantastic. I'm going to comment out all of these lines because now that I've manually put the craft in a reasonable orbit, we don't need to worry about actually doing these ascents. And the nice thing is we can just comment these out, and all of a sudden now our main program, we don't have to comment out these individual lines. We can just say, hey, don't call these functions because we don't need to worry about them anymore. Let's start actually writing code. Now, you may think, oh no, we need to learn a whole bunch about kOS to do this. What we want to do is we want to write our function that can execute any maneuver. And that seems pretty ambitious, right? Well, it is. So let's write a function to do it. Execute maneuver. And of course, that means we need to actually write we're calling the function up here in our main function. That means we need to write a function. And immediately we have a little bit of a problem. And that is that if we write the body, whatever we do inside here, if we write it, it's going to end up having to be specific to whatever maneuver we happen to have in mind, right? There's only one way we can write the code. It's going to go, all right, well, I'm going to point in this direction. I'm going to fire. I'm going to stop firing. And then we'll see what happens. What we want to do is execute a very specific maneuver. And we want to be able to call this with different parameters. Well, in fact, we can do that with functions. Just in the same way in math class, you say f of x is equal to x plus 2 or whatever. You're passing in x as an argument to the body of this function. We can pass in parameters, something, to a function. And in fact, when we call it, that's the reason we have these parentheses here, so we can put in these values. So I'm going to put in some values right now. I'm going to say times seconds, which is something we get from kOS. This means the current number of seconds in the game. This is the current elapsed seconds, so it's effectively right now. And I'm going to say plus 30. So I want to start my maneuver 30 seconds from now. That's when my maneuver node exists. I'm going to say I want 100 delta V in the radial and the normal and the prograde directions. So that's these are the parameters that I'm going to be passing to this function. I'm going to be passing in 4 values. If this was math, we'd be saying f of x, y, z, and I don't know, some letter after z, right? Functions, by the way, can also have return values, which is also very useful. I mean, in fact, with math, that's exactly what we're getting, right? It's whatever this thing evaluates to is going to be its return value. So what I'm going to do is I'm going to say here radial, normal, prograde, and then we had the universal time. And what I'm doing here is I'm saying that these are accepting parameters, and I want to take these values, and the first one I'm going to call U time, the next one I'm going to call radial, the next one I'm going to call normal, and the next one I'm going to call prograde. Now, the reason I've chosen these 4 values is because I already know a little bit about how kOS represents maneuver nodes, and there is a built-in function that gives us a return value. In fact, it gives us a maneuver node structure. So what I'm going to do is I'm going to call that function. That function is called node, and I can pass in those values, U time, radial, normal, prograde. And that's going to give me back something. So if I were to print this out, it would print out whatever it returns, but instead I want to assign it to a value. Now, we talked a bit about set. I'm going to call it MNV to node, but I can also ensure that this is a local variable. So local MNV is node, blah, 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 blah. And so this is going to call this function, passing in these values, and then give me a maneuver node structure, whatever the heck that means. We're not going to worry about what that means, because right now we're dealing with the high level of what executing a maneuver means. So assuming that now we have the required specificity of, hey, whatever values you pass in, this is the maneuver that I'm going to execute. What does executing that maneuver node look like? This is where programming with functions really shines, because we don't need to know the details of how kOS does stuff just yet. In fact, trying to figure out how kOS does a whole system of executing maneuvers is a challenging problem. It's better if we can break this down into small bite-sized chunks. And that's what we're going to do. We're going to talk about what we want to have happen, and we're going to use function names as the way to express that. So I'm just going to riff here. I'm going to say add maneuver to flight plan, and I'm going to pass in the maneuver, as an argument. So I'm going to say, hey, there's some function, add maneuver to flight plan, which doesn't exist. We haven't written it yet. And I'm going to tell it the maneuver that I want to add to the flight plan. I'm passing this in. That's why I saved it to a variable. I'm telling it, hey, go add this maneuver to my flight plan, and this is the specific maneuver that I want. And then that's all we're going to do. We're going to add that. Next, I want to do two things. I want to wait till kind of just before we're about to start burning our engine, so that we can steer toward wherever the maneuver is pointing us, wherever that target is. And then I want to wait again until the time when we need to start burning, and then I want to burn, right? So let's express that with functions. I'm going to say local start time. I'm going to create a variable called start time, and I'm going to say, I don't know how to calculate it. So it is calculate start time for this maneuver. Saying calculate start time, and here's the maneuver, by the way, that I want you to calculate the start time for. I don't know what it is, but we're assuming that it's going to give us back some sort of value that's going to be useful. We haven't written it yet. That's future us's problem. So start time is that. Let's wait until start time minus 10. Let's assume that's enough time for us to, get steering, right? Then we'll lock steering to maneuver, except I don't think that's valid syntax. I don't know. Can we lock steering? Is this something that is a steerable target? I don't know. Who knows if that's going to work? So instead, let's just call it a function, right? Instead of taking the time right now to jump out and go and look at the docs, let's just say point lock steering at maneuver target. And I'm going to pass in the maneuver again. Cool. Wait until start time. Lock throttle to 1. That one, that's kOS that I know. That's one that I happen to remember from stuff that we did before. Lock throttle to 1. Great. Then let's see. Cool. We're assuming we've locked the maneuver target. We've waited. It's time to start burning. We're throttling up. Well, now we need to figure out when do we need to stop. So let's see. Wait until maneuver. I'm going to call it is maneuver complete, and pass in the maneuver. And once that's done, lock throttle to 0. And I suppose we could also say remove maneuver from flight plan, and pass in the maneuver there too. So what we've done is we've written this function that actually describes how to execute a maneuver. And it describes it fairly well. It describes that process, that sequence of steps. What it doesn't do is worry about any of the details of how kOS works. In fact, the only bits of kOS, we have this line where we use node, which is a built-in function. We have some wait untils. We're locking the throttle. But the actual complex stuff we're hiding in smaller helper functions. Now, in the next video, we'll actually look at the kOS docs and start solving those individual problems. But in the meantime, let's go ahead and just write these bits of information. So let's say add maneuver to flight plan. That's got to be 1. That's got to take a parameter. And it's going to take a parameter MNV, not MVM, MNV. And it's going to do nothing, right? Because we haven't written it yet. So that's great. We'll put in a to-do here. Why not? And I'm actually going to copy and paste this because it's going to be relatively useful. We'll just do that. What's the next one we have? Add maneuver to flight plan. That doesn't exist. We need to write it. Calculate start time. Calculate start time. Wonderful. That also takes in a maneuver. This one actually needs to return a value because we're assigning it. We're saying start time is whatever calculate start time gives us back. So let's say return 0. Start time is 0. I don't know. That works, right? That's fine. We're not trying to make it right. We're just trying to make the code pass. Next, lock steering at maneuver target. All right, cool. Lock steering at maneuver target. Takes in a maneuver. We don't know how to do it. That's fine. We don't have to do anything. Is maneuver complete? Is maneuver complete? Parameter maneuver, return true. Yep, good job. The maneuver is complete. You're done. So we're waiting until that. It's going to say true. Fantastic. Remove maneuver from flight plan. Again, we're not doing anything. We'll worry about filling in what all of these individual small problems are, but tackling them individually is going to be a heck of a lot easier than worrying about some big complex thing where you're worrying about not just the inner details of, well, specifically, how do I lock the steering in a particular way? No, you're dealing with the entirety of how to execute a maneuver. Instead, we've already dealt with that entirety, and in fact, we can go ahead and check to make sure that our code runs, even though we haven't actually implemented anything that works. So I'm going to go ahead and print it ran at the very end here, and we can jump in and we'll see what happens. Immediately this pulls out, and What is it doing? Well, it hasn't crashed. We know that much. Ha! Actually, I found a bug already. Wait until start time less than 10. Well, that's not actually giving us any useful information. What we're actually looking at is whether time seconds is greater than start time minus 10. And the same thing here, time seconds is greater than start time. I think that may be what's causing nothing to move forward. Because we're not just waiting until this value is something that is true, we're waiting until the total elapsed seconds is greater than this number of seconds. And there we go. It ran. So that's fantastic news. This thing actually happens to work, which is crazy. And not only that, we were able to debug a problem with it before we had to figure out all of the little details. We were able to start working on things and improving things, and that's fantastic. This is why functions are so amazing. We've now broken down the steps of executing a maneuver into a couple of much smaller problems. And we'll tackle those problems in the next video by actually diving into the kOS docs and seeing the built-in ways that we can interact with maneuver nodes. So I hope to see you then. Stay tuned. Cheers.